Alright, today we're going to be going over calculating limits using limit laws. So the main things to take away from this section is we're just going to be finding the numerical limits using criteria that they give us and regulations. And also the squeeze theorem is introduced in this section, in which let's say limit as x goes to a of function fx and h of x, they're both equal to a constant L or C. And limit g of x is more than f of x and less than h of x. By the squeeze theorem, we can conclude that the limit of g of x is also equal to the same constant L. Alright, so let's start off with this question. Given that limit as x goes to 2 of f of x equals 4, as x goes to 2 of g of x it equals negative 2, and then as x goes to 2 of h of x it equals 0. So we need to find these answers. A is asking us limit as x goes to 2 fx plus 5 times g of x. So we just create a simple, addition little thing going on here. So as x goes to 2 of f of x, it is 4 plus 5, and inside this parentheses will be g of x, which is negative 2. So the answer you would have is negative 10 plus 4, that's negative 6. That's A. So B is limit as x goes to 2, g of x to the power of 3. So g of x is negative 2. So we just substitute negative 2 for g of x to the power of 3. That would give us negative 8. C is asking us limit as x goes to 2 of square root of f of x. So we just plug in f of x for 4 for f of x, square root it. That would just give us 2. And then for D is limit as x goes to 2, 3 times f of x over g of x. So we have 3 here, open parentheses, and then we plug in 4, and then on the bottom goes negative 2. This comes out to negative 12 over 2, which is also negative 6. Now we move on to E. So E is asking us limit as x goes to 2 g of x over h of x. So this would be g of x is negative 2, and then on the bottom would be 0. So this would be, I believe, undefined, because anything over 0 is undefined. And this question is limit as x goes to 2 g of x times h of x over f of x. So g of x is negative 2 times 0 over 4. Now this would just give us 0 over 4, which that gives us straight 0, because there's 0 in the numerator. So that's number 1. Alright, let's move on to number 2. The graphs of f and g are given. Use them to evaluate each limit if it exists. If the limit does not exist, explain why. So now instead of values, we're given 2 graph functions we have to deduct the answers from. So let's start with A. Limit as x goes to 2 f of x plus g of x. So 2 is right here on both graphs. So for f of x, as it goes to 2, y value reaches negative 1. So that would be negative 1 for the first number. And the second number, as on g of x, as x goes to 2, it reaches 2. That would just be 2, and then your final answer would just be 1. So for B, as limit x goes to 0, f of x minus g of x. So as f of x goes to 0, the y value hits 2. So we just do 2 here minus, and then g of x as it goes to 0, it does not exist. So that would be D and E. So your final answer would just come out to does not exist, because you can't subtract does not exist. So for C, as limit as x goes to negative 1, f of x times g of x. So negative 1 is right here. So for f of x, the limit is 1. And then for g of x, as it goes to negative 1, the graph reaches y value of 2. So 1 times 2 is just 2. And then for d, as limit goes to x, as x reaches 3, which is right here. So for f of x, as x reaches 3 is 1. And then on the denominator, g of x, as it reaches 3, it is 0. So this would just be undefined, because any number over 0 is just undefined. So now e, limit as x goes to 2, x2 multiplied by function f. So as x goes to 2, first we can substitute in 2 for x squared, so that we would have 2 squared, and then times f of x at 2, which is negative 1. So 2 squared times negative 1 would just give us negative 4. And then for this, I'm going to move that over there. So f is f of negative 1. So the y value of f at negative 1 is, was it 3? Because this circle is shaded in, which means that that's the point at that point. It doesn't necessarily have to be the limit. So that would be 3 plus the limit as x goes to negative 1 of g of x. That is 2. So 3 plus 2 is just 5. Alright, so let's move on to these few questions. And these questions were given an equation to plug the limit into in order to give us the constant answer. So for number 3, limit as x goes to 5 of 4x squared minus 5x. All we really need to do is just plug in 5 to x. And that would just give us 25, 100 minus 25, which is 75. And now for number 4, as limit goes to x negative 3, let's plug in negative 3 into this equation. 6 open parentheses negative 3 squared minus 9. So we're going to end up with negative 27 times 2 plus 9 times 5, 9 times 6, which is 54, and then minus 9. So we would have negative 54 on this side, 54 on this side, they cancel out, and then your answer would be 9 for that. Alright, number 5 is limit as v goes to 2. For this little equation, so all we need to do, same thing here, plug it in. 2 squared plus 2 times 2, and then next parentheses 2 open parentheses 2, and then to the power of 3 minus 5. So this would leave us in the first set of parentheses, we have 4 plus 4, that would be 8. And then in the next one we have 2 to the power of 3 is 8 times 2, that's 16, minus 5, that's 11. So it'll be 8 times 11, which gives us 88. That'll be answer to 5. Number 6 for this one, we as the limit as t goes to 7, we could also just plug it in. So if we plug in 7 to t squared is 49. 49 times 3, so 49 times 3 plus 1 on the top, and then on the bottom would be 49 minus 35 plus 2. So on the top we would have 49 times 3 is 147 plus 1, which is 148. And on the bottom we would have 49 minus 35 is 14, plus 2 is 16, And 148 divided by 16 is approximately, or it is 9.25. So that would be your answer. Number 7, let's see here. So limit as u goes to -2, and then we have square root a bunch of things. So same deal here. 9 minus -2 to the power of 3, and then 2 open parentheses -2 to the power of 2. So we would end up with radical 9 minus, here would be -8, but -9 minus -8 is 9 plus 8. And then on this side we would have positive 4 times 2, which is also 8. So we would end up with radical 25, which is also equal to 5. And now number 8, limit as x goes to 3. So same deal here, we can just plug it in. 3 plus 5, and then parentheses 2, 3 squared minus 3 times 3. So here let's simplify. So 3 plus 5 is 8. The cube root of 8 is 2. And then times, we have 3 to the power of 2, which is 9, times 2, which is 18. 18 minus 9 is 9. So 2 times 9 gives us 18. That is your final answer. Now number 9, limit as t goes to -1. So this is a bit long of a one, but we could also just plug it in here. And at the end we have to cube it as well. So t to the power of 5, -1 to the power of 5 gives us -1. So the first number would be -2 here, and then minus t to the power of 4, which is -1 to the power of 4. That just gives us 1, so -1. And then on the bottom we would have -1 squared is 1, times 5 is 5, and then plus 4. So we would be left with -3 over 9 to the power of 3, which is, it could also be written as 1/3 to the power of 3, which is just 1/3 times itself 3 times, which gives us 1 over 27 as our final answer. Alright, so let's try these questions by yourself. So you could pause the video real quick and try these out. Alright, so let's start with number 11. So number 11 is limit as x goes to -2 by the function 3x minus 7. So for this we could just plug in -2 to x, which is -6 minus 7, which just gives us -13. And now the next one, limit as x goes to 6, 8 minus half x. So again we could just plug in 6 for 8, which is half times 6. Now half times 6 is 3, so 8 minus 3 would just give us 5. Now number 13, as limit goes t goes to 4, we are given this. Now if you notice on the denominator, if you plug in 4, it just gives us 0, which would be that would just be undefined. So in order to counteract that, what we're going to do is factor out the numerator and see if we could do anything about the denominator. So if we factor out the numerator, we get t, and on one side we get t minus 4, and then t plus 2. We factor it out. On the bottom is t minus 4, and now look, we have two similar things here, so what we could do is cross it out, and we're left with t plus 2. Now we could plug in 4. So if we plug in 4, that just gives us 6 as our final answer. Now for 14, Same thing here, if you plug it into the denominator, it would just give you 0, which would be undefined. So what we're going to do is the same thing, we're going to factor it out. So on the numerator we could have x times x plus 3, and then on the denominator we could have x, and then we could have plus 3 and minus 4. So there's x plus 3 in the top and the bottom, so we just cross that out. We get x over x minus 4. So if we plug in -3, that would give us -3 over -3 minus 4, which is just 3 over 7. That's your final answer. So now for number 15, same thing here. If you plug into denominator, that will give you an undefined answer. So let's factor out the top. So x, and then on the top we could factor it out to x plus 4 and x plus 1, and then on the bottom is x minus 2. Now you could see, even though we factored it out, we can't get rid of this x minus 2 on the bottom or do anything about it. So this answer will just end up being D&E, or rather undefined. Since we can't get rid of the x minus 2 on the bottom, it just gives us a denominator of 0. Alright, for number 16 we have limit as x goes to 4. Now if you plug in 4, the 16 minus, this would also give you an undefined answer. So same thing here, we have to start factoring out everything. On the top is x times x minus 3, and then on the bottom we could do x, we could do minus 4 and plus 3. So we could just cross out 3 on both sides, and then we're left with x over x minus 4, just like the other question. Now the difference is here, as x goes to 4, it's we have to plug in 4 for x. So if we plug in 4 for x, we're given 4 over 0, which does not exist because it's an undefined answer again. Even though we factored out, we couldn't get rid of that x minus 4. Alright, and now number 17, as the limit as x goes to -2. So for this, it's a pretty long equation, so let's try to make it a little bit easier by factoring it out. So on the top we can do x minus 3 and then x plus 2. That works. And on the bottom we can do 3x on one side, x, and then we can do x minus 2 and then x plus 1. Or rather, actually minus 1 and then plus 2 here. So we could see here that x plus 2 is in the numerator and the denominator, so we just cross that out, and we're left with x minus 3 over 3x minus 1. So if we plug in -2 now, we would have -5 on the numerator, and then on the denominator we would have -6 minus 1, which is -7, and our final answer would be 5 over 7. Alright, so I want you guys to do these final 3 problems, 27, 29, and 32. So you could pause the video and do them. Alright, so for 27, we can see it's a little bit tricky of a one here, so what we could do in order to find the limit of something like this, in which it's 0 on the bottom and 0 on the top, is we can multiply by its conjugate. So conjugate is kind of like the opposite of it, so it would be 1 plus t plus there's a square root 1 minus t, and whatever we do on the top we have to do on the bottom as well. So on the bottom it would be parentheses 1 plus t plus square root 1 minus t, and then close parentheses. So if we multiply all that out, on the top we would have 1 plus t minus just 1 minus t. And then on the bottom we would have just t open parentheses square root 1 plus t, and then plus square root 1 minus t, and then close parentheses. Now on the top, that is possible because you guys have to remember one little formula. So a minus b times a plus b is always equals to a squared minus b squared. So that's a really important thing to remember. So now let's simplify for the stuff on the top. So the stuff on the top, if we simplify it, we get negative 1 plus 1 is 0, and then negative times negative t is positive t, plus t is 2t. So on the top we get 2t, on the denominator we get all of that same thing. Now you could see that t is shared on the top and the bottom here. So what we could do is cross it out. So now we're just left with 2 over everything that's here. All of this stuff here. So now what we could do is plug in 0 to all of this. So now if we plug in 0, we get 1 plus 0, and then plus square root 1 minus 0. So 1 plus 0 is 0, and then 1 minus 0 is 0. So square root of 1 is also 1, so 1 plus 1 is 2. So your final answer would be 2 over 2, which is also 1. So 1 would be the answer of this limit. Now let's move on to 29. Let's move it a little bit down here. So for this, same thing as 27. Let's multiply by the conjugate. So if we multiply that by, let's multiply by 4 plus radical x on both the top and the bottom. So if we multiply by both 4 plus radical x, we get on the top, we get 16 minus x. And then on the bottom, we get 16x minus x squared times 4 plus radical x. So what we could do is, on the denominator, we also could factor out the denominator. There's stuff to factor out down there. So we could do 16 minus x times x. So we factored out that x, and then this goes down here. So you can see the numerator and the denominator share something. So we can just cross that out, and we're left with 1 over x times 4 plus radical x. Now if we plug in 16, we would get 1 over 16 times 4 plus radical 16, which is 4, 6 times 8. And that would give us 1 over 128. That would be your final answer. Now for 32, let me isolate that space real quick. So for 32 here, we could do the same thing. We could multiply by the conjugate. So the conjugate would be radical x squared plus 9 plus 5. And then on the bottom we would do the same thing, square root x squared plus 9 plus 5. And now if we simplify the solution a little bit, we would get x squared plus 9 minus 25. And on the bottom would be x plus 4 open parentheses square root x squared plus 9, and then plus 5. Now we're left with this. So now I believe we could plug in -4, or rather we can't yet, never mind. So this over here, 9 minus 25 is 16, so this is x squared minus 16. Now if we rewrite the expression, it would be x squared minus 16, and then denominator would be everything that's here. Now we could factor this out. So x squared minus 16 is x plus 4 and x minus 4. Now the denominator would still be the same. Now we could cross out x plus 4 from both the numerator and the denominator. So on the bottom we would be left with square root x squared plus 9, and then plus 5 over here. So now we could just plug in -4 and then get the answer. So on the top, if we plug in -4, that would give us -8. And then on the bottom, -4 squared is 16 plus 9 is 25. Square root of 25 is 5 plus 5. That would give us -8 over 10. So -8 over 10 is our final answer for 32. And that's basically it for calculating limits using limit laws. And always got to remember stuff like conjugates, and then the squeeze theorem, as well as remembering to factor out, and so you don't have an undefined answer. But yeah, that's basically it.